Hey, let's start talking about naming ionic compounds with transition metals in them. Okay, sharing the screen this time. Good job, me. Okay, so transition metals, reminder, they have multiple potential possible charges, right? Like you can't just look at the column and see what the charge is. And so when you're naming compounds with transition metals in them, you got to figure out the charge of the transition metal ion, and then you got to represent the charge as a Roman numeral. Okay, so let's take a look at two examples. Yes, I know I did this already, but I'm recording it now. So, all right, FeO is iron 2 oxide. The way you figure this out is you know that oxygen is a -2 charge. There's only one iron here. It has to balance out the -2 charge from the oxygen, so it has to be +2. So we know that this is iron 2 oxide. This Roman numeral 2 represents the charge on the iron. Notice it's not Fe2O. Okay? The 2 is the charge on the ion. It is not the number of irons that there are. Okay? So that's the first example. FeO is iron 2 oxide. Fe2O3 is going to be iron 3 oxide because oxygen, again, is still -2. -2 times 3 gives me -6 total. These two irons need to add up to +6, so they have to be +3 each. Okay, +3 times 2 is +6. Oxygen is -2 times 3 is -6. +6 -6 is a net charge of 0. Okay, so, oh, cool. I put all the answers up there already. My wife's giving me the thumbs up. Thanks, guys. All right. Try these examples. Let me hide the answers. All right, so try these examples right now. Okay, so you're going to figure out what the charge is and then write what it is. Okay, and I'll just tell you now so you don't have to bother. And the nice thing about transition metals is you don't even have to look at the periodic table. So the nice thing is so you don't even have to look at the periodic table, so don't pull it up. So Sn is tin. I'll tell you guys that right now. All right. Ag is silver. Zn is zinc. Cu is copper. Okay. With the so you should be able to figure out what the charges are and then write the correct Roman numerals when you're naming these compounds. All right. I'll give you a couple minutes to do that. Okay. So SnCl4. A Cl has a -1 charge, which means Cl4 is what charge total? If you said -4, you are correct. Yes, 1 Cl is -1, but 4 Cls are -4. Does that make sense? Right? Because I have 4 Cls there. So that's -4 charge total. Okay? So to balance that out, Sn must have a charge of 4, +4, right? Okay, so we know that Sn has a charge of +4 and Cl is just chloride. So the way we name this is we call it tin, and I'll put it in the chat now. I'll put all the answers on the thing later. But it's tin 4, Roman numeral 4, chloride. Yes, like Katrina said. Okay, so it's tin 4 chloride because we know that tin must have a +4 charge. And then we call it tin 4 chloride. All right, so let's move on to SnCl2, right? So now the total charge of the Cls is what in SnCl2? Okay, if SnCl4, the total charge was -4 for Cls, now it's -2 for Cls, right? So if it's -2, now my tin gets what Roman numeral? Exactly, II. Tin 2. So, sorry. So it's going to be tin 2 chloride is going to be our answer here. Okay? So tin 4 chloride, tin 2 chloride. Now, Ag and Zn are exceptions. Does anyone remember what exception? I know it was like a couple weeks ago, but what did I say was special about silver and zinc a couple weeks ago? Yes, they only form one ion. Okay, so silver is always +1. zinc is always +2. So welcome to one of the exceptions for our transition elements. Because silver and zinc only form one ion, you do not put the Roman numeral. Okay? It makes it wrong. It's very annoying. Okay? But that just means AgCl is silver chloride, not silver 1 chloride. Okay? And ZnCl2 is zinc chloride. Okay, so if you see Ag or Cl, Ag or zinc, you just treat them as if they are any metal that always has a set charge. All right, the last two, CuBr2 and CuBr. Sorry, I said those backwards. Okay, CuBr. Oh, dang. I just realized I cut over the cut and paste answers that I had. But anyway, CuBr and CuBr2. Okay, Br has a charge of -1. So that first one, that copper has to have a charge of what? +1. So it's copper 1 bromide. And then the second one is copper 2 bromide. Okay, because Br2 has a charge of -2 and copper has that charge of +2 to balance it out. All right, let's see if this works. Yes. Okay, so here are your answers here. All right, these are your answers. This is already posted on Google Classroom, so if you need to look through it, you can look through it. Okay, going in the other direction, it's even easier because you don't have to memorize anything. You use the crisscross method again, but remember the charge, it's there for you now. So if we have iron 2 chloride, that means I know that my iron is a +2 charge. So I only have to find the charge from the periodic table for chlorine. Okay, the 2 says it's a +2 charge. All right, so then I have Fe2 plus, Cl1 minus. I just crisscross that and I get FeCl2. Okay, so you're going to use the same crisscross method and the charge is there for you. Okay, so let's just go through these examples since I wrote out the answers already. Cobalt 3 chloride. Chlorine has a -1 charge. So if it's cobalt +3, crisscross the -1 and the 3. You can imagine that in your head. COCl3. Cobalt 2 chloride is COCl2. Silver hydroxide. Notice again, silver does not have the Roman numeral. Hydroxide is an OH. AgOH. Zinc hydroxide, ZnOH2. All right, and then copper 1 and copper 2 nitride. Remember, I just give copper a +1 charge or a +2 charge, and then I just do crisscross like normal. Okay, so that is transition metals. It's not too much different than the regular metals. It's just that you have to either calculate or see from the formula what the charge is.